Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 3 of the 2024 released STAAR test. This is a new item type called drag and drop, and if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got drag and drop. So we need to put one number here. And you notice we could put 18 in both if we need to. So really, they're not limiting you to using each number once. And it looks like each number is up for grabs. So really, each of these spaces, right, are going to have 8 different choices to choose from. So that's quite a bit. And if we try to move on without answering both, it is going to give us our error message. So this is a 2-point problem. Let's get both points. We are looking at really a verbal description here. The value of y varies directly with x. Now, this is actually very important here. This refers to what we call direct variation. And it means that when we are looking at an equation here, a linear equation, when we've got y varying directly with x, the way we like to write it is y equals kx. Now, that's not on your reference materials. We had that back in 7th grade on our reference materials, and it's just not there anymore in our linear equations section because it's something we should know. Y equals kx means that there's just this constant right here, and that's the only thing changing x before it becomes y when you do the input-output. That is different than slope-intercept. So slope-intercept does not directly vary it because it's got this plus b. And this plus b shifts it up and down, right? And that's our y-intercept. So even though they both have this part right here, it's this plus b that changes from one to the other. So we're not using this. This varies directly, means direct variation, y equals kx. So it says when the value of x is 4, the value of y equals negative 12. Okay, so what is the constant of variation? Well, the constant is that k right there. That is the thing that's modifying the x before it becomes the y. Well, look what they gave us. They gave us a y and an x. So I can substitute in this y equals kx, I can substitute in negative 12 for y. I don't know the k, but I can substitute in the 4 for x. Well, now I can solve for k. That's pretty simple. Let's isolate the variable, and that is going to be divided by 4 for both sides. So we're going to get this negative 3. So k equals negative 3, because our constant of variation, if we do this right here, all we need to do is divide both sides by x. And so k equals y over x, which is this negative 12 over 4. We could have just immediately done that if we wanted to. All right, so the constant of variation is this negative 3. Let's put that in. But now, to make sure that we know what we're doing, we need to actually use it in substitution here. So what is the value of y when x equals negative 6? Okay, so let's say x equals negative 6. We have now gone ahead and let's put that in there. Y equals k to the negative 6. So that doesn't work on its own because it's got two variables, but remember, we just solved this. That's why they asked these two questions in sequence. The second one doesn't work unless you already know the answer to the first one. You have to know the k in order to do that. So now let's rewrite it with this k substituted as negative 3. All right, so now we're simply just multiplying negative 3 and negative 6. You see, we're going to get 18. All right, so when y is 18 when x is negative 6, and then the constant of variation is negative 3. And so that's really all we're going to do with this problem. The challenge here is that it's in words. It's not in numbers. You have to translate these words into numbers. So let's go ahead and put 18 right there. Those are our two answers for the 2 points for this problem.